Experts explain Africa is splitting in two, and it will look like this. Up close, the process is even more shocking, with a massive crack stretching from Mozambique in the south to the Red Sea in the north. This gap keeps growing every year, tearing apart the land and destroying homes. Now, specialists believe the continent could split much sooner than we expect. Africa is breaking apart because of the Somali Plate movement. Think of it like a dramatic breakup happening with tectonic plates. On the east side, there's the Somali Plate. On the west, we have the Nubian Plate. And during this breakup, the Somali Plate just wants more space, so it's pulling away from the Nubian Plate. This movement is forming the East African Rift, a region where tectonic plates are splitting apart, magma keeps rising from deep below, and a bunch of active volcanoes are being born. So this place is hot, with daytime temperatures that can soar to 130 degrees Fahrenheit, and at night they cool down to 95 degrees. Inside this hot zone, we have the Afar Triangle, also known as the Afar Depression, and its geology is fascinating, as the rifting process is causing valleys, faults, and deep cracks to form in this region. Take, for example, this massive 35-mile-long fissure in Ethiopia's desert. It's also so wide that a person can easily fit inside of it. But what's scary is this crack keeps getting bigger, growing about a half an inch every year. The Nubian and Somali plates moving apart could also lead to a new ocean forming in Africa. This type of process isn't something new. About 150 million years ago, when dinosaurs were still around, a similar tectonic shift created the Atlantic Ocean. The continents were once all clustered together, but when a rift formed in what was Pangaea, it started pulling them apart, splitting the east and west hemispheres. So, a similar thing is happening with this gap in Africa. At some point, experts say the waters of the Indian Ocean might flood the East African Rift Valley, eventually creating a sixth ocean. Now, it's a pity you won't be able to swim in its waters during your lifetime, though. According to geophysicist Ken McDonald, who specializes in tectonic faults, this dramatic rupture could happen in 1 to 5 million years. Trust me, that's considered fast in geologic terms, and way sooner than most experts thought. Now, even though you won't get to watch Africa breaking apart, people there will still see and feel the signs. They might experience intense volcanic eruptions and strong earthquakes as this process slowly unfolds. One example is related to that scary crack in Ethiopia's desert we mentioned earlier. The fissure was created in 2005, after the area was hit by 2 volcanic eruptions and 163 earthquakes, each with a magnitude greater than 3.9. A crack this deep and long on Earth usually takes centuries to form, but in this case, it unfolded in just a matter of days. That's how powerful this event is. In fact, this kind of intense seismic activity can speed up the African splitting process, and that's why it's so hard to predict the exact time frame for the event. What we know is that people are already calling this new land the Nubian continent. If the predictions are right, it will include Somalia, Kenya, Tanzania, and part of Ethiopia. That's exciting and concerning at the same time. As new coastlines emerge, countries will need to make major adjustments when it comes to infrastructure and land management. They might lose a lot of roads, houses, and other constructions currently located near or right in the East African Rift. In Kenya, for example, the fissures tore apart a busy road, and authorities desperately tried to fill the gap with rocks and cement. In another case, an old woman was sitting and eating with her family when her house suddenly split down the middle. Recently, earthquakes that happened near Ethiopia's Afar region demolished 37 schools and forced about 5,000 students to leave their classrooms. Unfortunately, stories like this could become more common over the next few years. But there is a positive side to all this. Countries located in the middle of Africa, like Zambia and Uganda, could gain coastlines, and that might be great for them. Having a coast means they would get access to new trade routes, opening fresh economic opportunities. Plus, think about the tourism boom. With all those newly formed paradisiacal beaches, these countries could become the next big gateway spot for travelers. The local ecosystem in this newly created ocean will change as well, and new marine species may emerge. So let's look. This is the path where the rift is most advanced right now. I mean, we expect this is where Africa will eventually get separated. But things could get a little more complicated. Some time ago, Michael Daly, a geologist at the University of Oxford, suggested that this rift could extend further west. And some new evidence backs up his theory, pointing out that the crack could extend south through Botswana's heartland into South Africa, and west through Namibia, all the way to the Atlantic Ocean. If these fractures widened into deep cracks, the ocean might come in and fill the gaps. Experts say Africa could split so much that it becomes an archipelago. But then again, we won't see that happening. It will take tens of millions of years for this to play out. We already know that Africa is at risk of breaking into a bunch of huge islands or small continents. The news isn't great for Madagascar either, as the world's fourth largest island could end up being split in half. But can the opposite process happen? I mean, can new land appear as the Nubian and Somali plates move apart? Well, as these tectonic plates get away from each other, the magma from the Earth's mantle might rise to the surface, and when it cools, it solidifies into new land. That's how other places in the world emerged, like Iceland and the Azores. So, yeah, the same process could happen in the East African Rift, and over the long term, it is possible that the rift could create new islands. For now, all we can say is that the geology of the Afar Depression is unique. It is the most active rift system on our planet. And when I say rift system, I mean a zone where tectonic plates are pulling apart. This region brings together all kinds of events, from faults in the Earth's crust to volcanic zones to the potential formation of a sixth ocean. For experts, it's like studying the evolution of rifts up close. And since it is such an active volcanic area, it also has enormous potential for tapping into geothermal energy, that is, using heat from inside the Earth to generate electricity. 2 geothermal power plants are already producing energy in Ethiopia, one in the Ethiopian Rift Valley and the other in the Afar. Now, geologists are exploring new potential spots. When we look at that deep crack in the ground, we know it's caused by tectonic plate movement. There's no mystery there. But what we still don't fully understand is why the cracks happen exactly where they do. For example, a crack that opened up in Botswana appeared after a magnitude 6.5 earthquake back in 2017. But the epicenter wasn't in the rift zone, where the plates are moving like we would expect. Instead, it was farther south. Since it's unusual for a rift to happen without volcanic activity, this fact really challenges our traditional ideas of how continents divide. Figuring out why these cracks appear in specific spots is still a missing piece of the puzzle for experts trying to explain how Africa is splitting. Hopefully, we get some answers before the continent turns into a massive archipelago.
India could split horizontally into 2 parts as it runs into Eurasia. The movement of the Indian plate that includes most of modern South Asia is causing the Himalayas to grow. This process started around 60 million years ago when the plate first bumped into Eurasia. Scientists from the Netherlands have used the power of an AI simulator to see what this region will look like one day. The computer model showed that the Indian subcontinent will merge with the Horn of Africa in approximately 200 million years. The present-day cities of Mumbai and Mogadishu will become next-door neighbors. They will sit along the newly formed mountain chain scientists provisionally named the Somalaya. On the other side of this geological formation, Madagascar will connect with Sumatra, while Calcutta and the island of Mauritius will occupy the same region. Sri Lanka would cease to exist as it becomes part of the Indian mainland. Further to the north, scientists predict that the Himalayas are going to increase in height in the foreseeable future. As the Indian plate continues to mile northward, there will be major changes to the surrounding landscape. The present fault line will drift further south. Tens of thousands of years in the future, there might be no Nepal. The Himalayan range will have expanded sideways to fully engulf the mountainous country. And there may be way more earthquakes in this part of the world because of this movement. Most researchers agree the speed at which India is moving northward into Eurasia is barely a tenth of an inch every year. Some of them think this is happening because of the plate's buoyancy. It prevents the Indian plate from sinking into the mantle, which gives Tibet its elevated topography. Other scholars believe that the structure is buckling under the pressure. The process resembles what happens to a sheet of paper when you push it horizontally against a wall. As you apply more pressure to its edge, the sheet starts to rise in the middle. In the real world, this bulge would be the Tibetan Plateau. A recent theory gives us the third explanation for the process. Their paper still has to undergo peer review, but the findings are intriguing. The international team of researchers introduced a new concept, the delamination of the Indian plate. This term simply means the separation of layers in a material that is supposed to be bonded together. Think of a sandwich that has cheese and ham slices between two buns. Take one of those layers out of the sandwich, and you get delamination. In geological terms, this process involves the upper part of the plate peeling off and moving upwards. In the case of the Indian plate, this is the section that supports Tibet's elevation. The lower section is denser, which causes it to sink into the mantle. Plate tectonics are, in this way, similar to a layered cake. Chefs place the spongy, denser layer at the bottom, so the heavier top doesn't crush it. Scientists developed their thesis by analyzing helium gases in water samples from the region's hot springs. Helium-3 is a rare isotope that shows that the mantle is close to the surface of the Earth. Researchers measured helium isotope ratios at 200 Tibetan springs. The pattern they saw shows how close the mantle is to the northern Tibetan surface. Further to the south, they found plenty of helium-4, another isotope, which means that the plate is intact. It forms a barrier that helium-3 cannot penetrate, except in one region near Bhutan, in the eastern part of the Himalayas. The seismic activity in the region is good proof that delamination, the sandwich theory, is all real here. And it shows us that the mantle is intruding from the eastern side of the plateau. This concept puts under question the old, established ideas about tectonic plate behavior. The scientists behind the study suspect that the unique shape of the Indian plate contributes to the delamination process. It's the thickest at the northernmost point and the thinnest on the sides. If it's all true, it will mean that the continental collisions have a more dynamic and complex nature than geologists previously believed. Scientists still don't have enough hard evidence to prove the correctness of the new theory, just hints. Drilling to depths of over 60 miles is mechanically impossible right now. Such excavations are necessary to be 100% sure that the delamination process is going on. With the right technology, we would be able to better understand the hazards associated with earthquakes in the Asia-Pacific region. It's home to the famous Ring of Fire, where 75% of Earth's volcanoes are located. 9 out of 10 all earthquakes take place here. The India-Australia-Capricorn tectonic plate beneath the Indian Ocean is also important for solving Earth's tectonic mysteries. The term geophysicists use for such locations is nascent plate boundary. These are plates where tectonic plates are just starting to pull apart or push against each other. They represent the initial stage of a full-fledged plate boundary. Such a geological transformation unfolds at a pace of barely 5% of a single inch per year. That's about as long as a strand of spaghetti is wide. This shouldn't worry us too much from today's perspective. The India-Australia-Capricorn plate is destined to split in half over the course of tens of millions of years. Scientists from France studied records of 2 earthquakes that happened in 2012 and concluded there must be a nascent boundary there. Earthquakes normally occur at places where two or more tectonic plates meet. But the tremors in the Indian Ocean happened in the middle of the plate. The scientists used sonar scanning to map out the sea floor and see what was really going on there. After further examination of the marine area off the coast of Western Australia, researchers found a complex network of 62 pull-apart basins along a fracture zone. The scientific data backed up the idea that the tectonic plate was slowly but surely breaking apart. It's another proof that the outer layer of our planet is dynamic, not static. In some cases, you don't have to be a scientist to notice these powerful underground forces. Massive crevices emerged almost overnight due to heavy rainfall in a seismically active region in rural Kenya. First in 2018 and then again in 2023. The local population named the biggest of them the Grand Canyon. These events were not one-time incidents, but signals from the East African Rift System, part of the Great Rift Valley. This huge geological phenomenon stretching from Jordan to Mozambique shows us the gradual splitting of the African continent into two subcontinents. You can find rift valleys all around the world as proof of how tectonic plate movements are changing the planet. The East African Rift shows the underlying dynamics of the Nubian and Somali plates. The Nubian plate bears most of Africa, and the smaller Somali plate cradles the Horn of Africa. The two are gradually moving away from one another, which causes the formation of crevices within the Rift Valley. This process of continental rifting, going on at a rate slightly faster than the one in India, will eventually lead to the split of Africa into two continents. The whole process, which is about to happen in the next 10 to 50 million years, marks a significant geological event that reminds us of Earth's historical transformations. The last time our planet's geography changed so drastically was during the Jurassic period. The world map from the period looks recognizable, but the land masses were oddly positioned from the modern perspective. In the north, Eurasia was still loosely connected to North America, which was at the time called Laurasia. This landmass was slowly moving away from the supercontinent of Gondwana, further down south. It consisted of what we know today as Africa, South America, Australia, and Antarctica. At the time, the Indian plate was closer to Madagascar than to Eurasia, as it is today.
You plan to spend your summer vacation in Africa. The final destination is the Sahara Desert. It's located in northern Africa, stretching from the Atlantic Ocean to the Red Sea. You're excited to ride camels and learn about the region's rich cultures. You hop on an extensively long flight, and finally, you are here. You find yourself in the world's biggest hot desert. Can you believe it's 3 million square miles? You're ready for your first adventure after drinking liters of ice-cold water. The guide gives you a choice. You can spend 2 weeks visiting a collection of oases, or you can help them solve an ongoing local mystery. Deep into the desert, near this Algerian town, lies a mystery begging to be solved. A collection of huge, spotted circles in the sand. There are dozens of them, stretching for miles in a straight line. The circles were first identified via Google Earth images several years ago. People have debated them for years, but no one seems to know the answer. The strange thing is that they are so many miles away from any towns, roads, or human activity. The quickest way to discover the truth behind the circles is asking questions. You grab your notebook and set out to talk to locals. Everyone is helpful in this scenario: geographers, anthropologists, elders, and historians. The first person you talk to is a map expert. You need to understand if those circles were authentic or a satellite glitch. You end up interviewing the people who take Google Earth satellite pictures. The circles are really there. They appear in multiple pictures from many years. Then, let's understand why they are there in the first place. After 2 days of interviews, you have your first lead. The circles could be the result of oil activity. Experts explained why this would make sense. Algeria is a rich area for natural resources, so this would be a sensible guess. Usually, to find out if there is anything worth extracting, companies would undertake seismic surveys. Seismic surveys are a way of analyzing the Earth's surface by sending shock waves into the ground. Depending on how these waves bounce back, you'll know what is located there. A special vehicle could have marked the soil that way. So, did we unravel the mystery? Not quite so. As you know, the Sahara Desert is one of the driest areas on the planet. The average high temperatures in summer are over 104 degrees Fahrenheit. To survive there, people need to find ways of accessing water. So, these circles could be a kind of ruin or leftovers from ancient water wells. Again, I'd say this is a sensible guess. Ready for some fact-checking? Some anthropologists agree that these circles could be ancient fogueras. Foguera is the name of a 2,500-year-old style of irrigation system, usually found in northern Africa. It is also known as a qanat in other places in northern Africa. Locals would dig a deep well at an elevated point, deep enough to tap into underground water. They would then dig parallel shafts at regular distances. Then, they would dig an underground channel that connected the city to the well. Solely with the help of gravity, water would run from the well to the city. This traditional technology provided water for crops, livestock, and humans. Now, let's say these wells made human-made oases possible. Even the closest municipality name was an indication that this could be true. The name Fogueret Essaouira is actually named after Fogueras, these ancient wells. Now, this lead was proving to be very accurate. You decide to travel over there to see for yourself. You take a local bus, sit back, and enjoy the ride. The landscape in northern Algeria is filled with ancient-looking towns. You even see ruins of wells along the way, on the outskirts of smaller cities. Opening Google satellite images, you can see the qanat's markings on the ground, a series of holes running down several miles. But as soon as you arrive, you find out you were wrong. Dale Lightfoot, one of the world's leading experts on qanats, said that the circles were definitely not qanats. Even the satellite images confirm this difference. Uh-oh, we were so close. Apparently, qanats or fogueras would not run down a straight line. They wouldn't be shaped like circles. Another clue that this wasn't the case was that there were no towns at the end. The circles were really far away from any human activity, and qanats were explicitly built to provide water for human settlements. Well, it sure was a good try. You almost gave up on this mystery when you decided to take one more field trip. It was days of preparation, pick up cars, food, equipment, all so that the mystery of the Sahara Circles could be unraveled. On the first day, you drove over 99 miles into the desert. You were always curious to see what this part of the world looked like. Over there, you see nothing but mustard yellow dunes. The night sky is pretty decent, though. You can see the entire Milky Way with your own eyes. You set up camp and sleep under a canopy of stars. The next day, tension grows. There's no cell reception. Oh dear. But thankfully, you added the coordinates of the circles to your Google map. And surprise, the offline mode works out there. You follow the coordinates, but it leads you astray. You start to get nervous, thinking this was all in vain. But you and the team get into the car and drive a few more miles past the coordinates on your phone. After a very bumpy ride, you can't believe your eyes. There it is, an enormous crater dug on the sand, surrounded by 12 smaller holes. From up high, it looks like a clock, without the pointers, of course. On the ground, they're very faint, so faint you almost miss them. Searching the area, you notice all the holes had something similar, metal wires, thin wires that you can pull from the ground. They're buried deep, so you start digging. An object starts to reveal itself. Uh-oh, it looks like old dynamite. This certainly surprises you. Better stop digging to avoid any accidents. At the end of the survey, you feel satisfied, but still curious. What could all this dynamite mean? And who put it there? What comes next is the turning point of your adventure. Walking back to the car, you see something shining on the ground. You approach the item with curiosity. It's round and rusty and looks like a sardine can? What's that doing here? Could this give you more clues about the circle's mystery? Just in case, you pick it up and put it in the car. Back in the city, the puzzle pieces start to reveal the story behind the Sahara circles. You bring photos and the sardine can and show them to local experts. They analyze your material and give you an intriguing verdict. As it turns out, guess number 1 was the closest one to the truth. So, what happened to the first guess? Why do we need to keep digging deeper? Well, because it was only half right. The Sahara circles are not a historical footprint of seismic surveying. Back when the circles were made, this technology didn't even exist. But they sure are related to oil exploration. The dynamite-filled holes were an old method for oil searching. The circles are the leftovers of surveyors looking for resources underground. And the sardine cans? Well, they were left by the workers who held explosion works. You gotta eat, right? According to the model of the can, this happened more or less around the 1950s and 1960s. So these circles aren't even that ancient. More like modern ones, if you ask me. Well. Hope you are glad you tagged along and helped unravel this mystery. See you in the next mystery-solving adventure. You find yourself in Africa, land of unique wildlife, home to a great variety of cultures and languages, and, first and foremost, host to the world's largest hot desert, the Sahara. It's daytime, and you are thirsty for some water and shade. You've been walking for days, trying to find one of those precious-looking oases. You feel you're near, but the horizon just keeps stretching and stretching. Your mind is tired, and your body is feeling all the heat. It's like you've eaten a full plate of hot pepper and then some more, judging by how much you're sweating. And when I say hot, think 100 degrees Fahrenheit hot, on average. No wonder this is happening. After all, you find yourself in the world's biggest hot desert. Now, I say hot desert since the biggest deserted landscapes are actually the cold ones, located in Antarctica and the Arctic. I see Antarctica's frozen desert is more or less the size of 1 million LAXs. Yep, the Los Angeles International Airport. The Arctic desert is just a bit smaller than that. Now, in case you don't know, the Sahara Desert is located in northern Africa, stretching from the Atlantic Ocean all the way over to the Red Sea. It occupies an area large enough to place approximately 100,000 Disney World theme parks side by side. According to scientists, its boundaries are expanding. Deserts usually form in the subtropics because of what's called Hadley circulation. The air rises at the equator and descends into the subtropics. This circulation of air has a drying effect, which helps the formation of desert landscapes. Since the 1920s, the Sahara is considered to have expanded by over 10%. How is this happening? Well, let's start from the beginning. You probably know the Sahara Desert as one of the most inhospitable places on Earth today. Just FYI, for a place to be considered a desert, it has to receive less than 4 inches of rain per year. Due to the very small precipitation index, deserts are usually dry and arid places. There is little humidity in the air, and daytime temperatures can go as high as 130 degrees Fahrenheit. Usually, there isn't that much animal and plant life because of the lack of water. But in the Sahara's case, it wasn't always like that. It may be difficult to imagine northern Africa without the tons of sand it has today. But about 20,000 years ago, the Sahara was actually one big oasis. Recent discoveries show clear evidence of what the scientists now call the Green Sahara. In the mid-1800s, a German explorer crossing the Sahara encountered some paintings and engravings that nomad artists had left behind. What he saw in those paintings looked nothing like his actual surroundings. Instead of an arid landscape with only camels and desert vegetation, the rock paintings depicted jungle animals like giraffes and hippos. There were even images of livestock and grazing animals such as cattle and sheep, something that seems impossible for modern-day Sahara. Artists usually draw what they see around them, so this finding really intrigued the German explorer. The drawings were so detailed that the artists must have had close contact with those animals. You can find this rock art spread out in the northern part of the African continent, from western Sahara to Saudi Arabia. Geologists soon took a keen interest in this and found the first clues to what this could mean. They have been able to confirm that, in fact, northern Africa was once much wetter. They found evidence from nearby deep-sea sediment off the coast of Mauritania. Sampled cores of underwater sand and mud, known as Saharan dust flux, showed geologists that, indeed, a green Sahara was possible. The more dust is blowing off of the desert and into the bottom of the ocean, the drier the climate in the region. The sediment cores show that there was much less dust, only half as much, coming off northern Africa during the humid period. This period has to do with Earth's natural cycles. Normally, the Earth rotates at a tilt of 23.5 degrees, but this angle is not consistent and changes over time. Earth's tilt is responsible for the amount of sunlight each hemisphere receives. It affects several ecosystem functions on the planet. During the time of the Green Sahara, the Earth received between 4 and 8% more sunlight than it does today. So, when the Earth tilted about 20,000 years ago, the northern hemisphere received more direct sunlight, which affected humidity levels in the region. As the northern hemisphere got warmer, this affected monsoon activity, more specifically, the West African monsoon. Monsoons are wind systems that affect a region's rainfall index and humidity levels. As a part of the globe gets warmer, it allows for more air to rise. It combines with the wind to draw moisture up into the atmosphere. Little by little, northern Africa also became wetter. The increased moisture made the Sahara so wet that there were actual bodies of water in the region. As vegetation grew, the plants held onto moisture better than bare sand could. There is evidence of natural basins throughout the Sahara and lakes so big they would fit all of the U.S.'s Great Lakes inside of them. Archaeologists uncovered evidence of vibrant societies in what are now arid areas. It looks like ancient cultures were able to take full advantage of the African humid period. According to researchers, the human population peaked across the Sahara about 9,000 years ago. There are traces of fireplaces, hunting tools, fish hooks, and even mounds of fish bones. Records show that there have been over 230 green periods over the span of 8 million years. Solar radiation is always changing due to natural orbital cycles. That's why Earth will most certainly see another green Sahara moment. It might be thousands of years from now, but it will happen. The same way the Sahara turns green, it turns yellow again. Let's put it like that. All it takes is a significant axial tilt and a few years of readjusting. However, another phenomenon is calling the attention of scientists now. Recent studies by the National Science Foundation from the University of Maryland show the Sahara has expanded 10% over the past 90 years. This phenomenon is called desertification, which literally means fertile land turning into desert land. The Sahara Desert is now advancing into the semi-arid region of Sahel. In 1950, this region was home to 31 million people. Today, its population is over 100 million people. This rapid population growth has largely contributed to the Sahara's expansion. Farmers that were once nomads began settling down. Land usage grew more intense, aiding in weakening the soil. The demand for food has caused an overcropping of the land, so even more of it is turning into the desert now. The study also shows that natural climate cycles can affect rainfall in the Sahara and the Sahel. Scientists affirm that all deserts fluctuate, not only the Sahara. A desert's boundary may expand in the dry winter and contract during the wetter summer. South of the Sahara lies the Chad Basin. It is a natural body of water that now serves as an indicator of the Sahara's expansion. The Chad Basin is located in the region where the Sahara is advancing southward. An atmospheric and ocean expert from the University of Maryland explains that rainfall has reduced greatly in the entire region. Due to reduced rainfalls, there is less water across the entire basin, and even Chad Lake is drying out. Just like the Sahara, the Atacama Desert in Chile, deemed the world's driest, is also expanding. It is located north of the city of Santiago, and its southern border is expanding toward the Chilean capital. Because the climate is getting drier and drier here, the city of Santiago risks turning into an arid or semi-arid region itself. The once fertile valleys of local rivers that lived on agriculture and livestock for many generations are losing their revenues as Chilean land is turning into a desert. Since 2010, Santiago has received only a third of its annual rainfall. Outside of the city, farmers are digging holes in search of blue gold, or simply put, water. The situation here is very similar to that of Sahel. So tell me this, were you as surprised as I was to find out what has been happening in the Sahara region? Feel free to share in the comments below.
Phew! This summer has been turning up the heat like never before. We feel like roasted marshmallows on a sizzling grill. Yes, the world is getting hotter, but some regions have always fought with high temperatures. It turns out people had some inventions to keep themselves cool in ancient times too. Some of them are still functioning, even 3,000 years later. Let's take a look at how people saved themselves from heat throughout history. So, put an ice cube into your cold drink and get ready to hear how people survived the heat. Speaking of ice cubes, do you know that the Persians made an ice storage system? In the deserts of ancient Persia, people had an out-of-the-box idea about how to prevent their food from turning into a melted mess. These ingenious Persians stumbled upon a physics trick that allowed them to create ice in the middle of the desert. They called these cool structures yakhchals, which basically means ice pits. These ice pits were not your ordinary coolers. They were like secret underground fridges. They looked like dome-shaped mud brick structures on the outside, but inside, it was a whole different world. These ice pits had an evaporation cooler system that worked like magic. At night, when the desert cooled down, Persians made use of the radiative cooling effect. They set up cleverly designed trenches to hold thin layers of water. The water froze, defying the desert heat. Then there were underground square storage areas. The Persians collected the melting ice water from these cool trenches, and during the night, they froze it again, making the most of the desert's natural chill. To add to the cooling effect, they built a wall to shade the storage areas from the hot midday sun. And that's not all. They had this fantastic wind-catching contraption called a badger that caught the breeze and directed it right into the ice pits. Fresh air plus ice. Cool breeze. A winning combo. They even had intricate water channels called qanats to bring water to the ice pits and homes all the way from the nearby mountains. As time passed, these yakhchals faded into history and modern technology took over. But hey, there's good news too. Some awesome folks in Iran are restoring these ancient coolers. So, if you ever find yourself in the desert, don't forget to pay a visit to these marvelous places and witness the genius of the ancient Persians firsthand. Now, I want to focus more on the wind catchers because they don't just help make ice cubes. They actually function as a cooling system as well. Back in the day, those clever architectural wonders were all the rage in places like Persia, modern-day Iran, Egypt, and the Middle East. Imagine tower-like structures with openings at various levels strategically placed to harness the power of nature's breeze. These openings were like magical portals for the wind. They captured those refreshing gusts and guided them right into people's living spaces. Basically, they were natural air conditioners. The breeze would gracefully flow downward, cooling the ground as it danced through the building. The secret sauce lies in the details. The tower's height, the number of sides, the openings, and the positioning of the interior blades. Everything plays its role in how efficiently the wind towers work out. Thanks to these wind catchers, ancient societies could enjoy comfy indoor temperatures without sweating. Can you imagine living in those times? Feeling the gentle breeze whisking through your home, keeping you feeling fresh and chilled out? The Persians are often credited for inventing these awesome wind catchers. But hey, don't forget about Egypt. There, you can find traces of similar structures dating all the way back to 1300 BCE. Yes, the invention of wind catchers may have occurred in ancient Egypt, but Yazid in Iran is the city with the largest number of wind catchers. People wouldn't have been able to live there without these ancient ACs because there was almost no rain in the area throughout the year. Now, let's look at these perforated double-skinned exteriors. Imagine dressing up a building with a fancy perforated screen. It's like giving its exterior a stylish makeover while keeping things chill inside. This genius technique, firstly, scatters the natural daylight, so no harsh sunbeams to blind you. The screen also offers shade like a pro, giving the building's interior a much-needed break from the blazing sun. Think of it as a natural sun hat for your home. Placing this screen about 4 feet away from the outer walls creates a breezy, dreamy hallway for fresh air circulation. And hey, they add a touch of elegance to the building too. These structures are sometimes called jali. Jaipur, India, for example, has an average daytime temperature of about 100 degrees Fahrenheit. So these structures are lifesavers. Jalis come in various forms, crafted from cement, earth, and wood. It's a cultural symbol deeply embedded in Indian architecture. You can find its captivating presence in iconic historical buildings like the majestic Taj Mahal and the Grand Red Fort in Delhi. But hey, it's not just a thing of the past. It's still rocking modern architecture scenes, and its charm has sparked creativity in artists and designers worldwide. It adorns the building's exterior, its cross-section showing a larger opening on the outside and a smaller one on the inside. This is where the Venturi effect steps in to show off its physics prowess. As the air flows through the narrowing passage, it picks up speed, creating a difference in pressure between the inside and outside of the building. Air blowing at a higher speed gets compressed, and when released, it cools down. Mashrabia is a wooden lattice or screen used in the Middle East and North Africa. These decorative wonders are like window blinds, but they do more than just look pretty. They're smart too. They give privacy, shading you from the sun, and let fresh air and light in. Some people also add clay pots filled with water, sand, or damp straw to their designs. As hot air breezes through the holes, it also passes through the pot's porous surface. The moisture inside evaporates, cooling the air. This is a perfect low-cost technique for hot and dry climates. It's eco-friendly, and there's no need for electricity. Now, let's fast forward to today. Designers are getting creative, mixing traditional wisdom with modern tech. At the Al Bahar Towers in Abu Dhabi, they've got it too. Picture over 2,000 hexagonal panels that dance with the sun's movement, providing shade to the building's interior. Water evaporation was another secret weapon for ancient people. Simple, yet super effective. Plus, ancient Egyptians hung wet mats and curtains in doorways. When the air passed through them, it cooled down, providing a relief from the scorching sun. Ancient architects were the masters of maximizing airflow. They knew how to cross-ventilate and let hot air escape while inviting cooler air to the party. Speaking of ancient Rome, bathhouses were the place to be back then. It was like a community hub. People gathered to chat about politics, play sports, and, of course, take a relaxing dip. The frigidarium was the cool spot in Roman baths. After a steamy soak in the caldarium, Romans dashed to this giant pool to chill out. Then in some places, like Cappadocia in Turkey, people went underground to hide from the heat. They carved cozy dwellings in volcanic rock, harnessing the Earth's natural cooling powers. So the lesson here is simple. Architects and designers can create wonders by combining local traditions with smart tech. California's Death Valley boasts the highest officially registered temperature to date, with 134 degrees Fahrenheit in 1913. Meanwhile, Africa's sweltering record stands at 131 degrees Fahrenheit in Kebili, Tunisia, as noted in 1931. In Europe, the highest temperature ever documented reached almost 120 degrees Fahrenheit in Sicily in August 2021. Then, in 2022, the UK had the hottest summer of all time.